This lesson is on Unit 1, Lesson 9 for Direct Variation, Part 1. So just some quick vocabulary for direct variation. We have a direct variation equation that relates f of x with a constant value times x. And f of x is our y values and x is our x values. So x is our inputs and f of x represents our outputs. And the constant of variation is a constant value, k, for the entire relation. And if you remember back for what a relation is, it's just a grouping of ordered pairs. So with a direct variation, they're all related by a specific constant value, and we call that the constant of variation. So what direct variation looks like, as x increases, y increases by the same factor, and that same factor is k. So if x is going to increase, y also increases. For direct variation, the direct variation equation, f of x equals k times x, and it's also the same as y equals k times x. So notice it uses either f of x or y. F of x and y are the same value. They represent the same number. And they also give you this equation that's easier to find the constant. These two equations are the exact same. This one is just reordered and solved for k, so you can easily see what the constant of variation is. And graphs of direct variation are always going to be straight lines, and they will always go through the origin, so through that point 0, 0 on a graph. So again, direct variations are straight lines going through the origin. So to determine if you have a direct variation, you're going to be using the direct variation equations. So f of x equals k times x, where k is a constant value for the entire relation. And you have to find that constant value by taking the f of x divided by x. So if we have a table of values, this table represents a relation because there's a set of ordered numbers or ordered pairs. So we need to determine if it's a direct variation. So we want to find k. So to find k, we're going to use this equation, f of x divided by x. So in this case, y divided by x. So 8/2, 8 divided by 2 reduces to 4. So the k for this one, k equals 4. If we set up this one, 16 divided by 4, that also equals 4, so the constant is 4 for this one. 24 divided by 6 is 4, so the constant for this ordered pair is 4. 32 divided by 8 is also 4, so the constant for this one is 4. And lastly, 40 divided by 10, the constant for this one is 4. So because each of our constant values equals 4, we would say that this one is a direct variation because k was the same for each ordered pair. So this one is yes, it shows a direct variation because when we calculated out k was the same value for each of them. It was a constant value. This next one, we're looking at the equation. We have f of x equals x minus 12. We want to compare to see if it's in the format of the direct variation equation. The direct variation equation is f of x equals k times x. So it should look like a number times x. So when I compare this equation, looking at this piece here, this does not show a number times x. It's showing x minus a number. So because it's not in this format, a number times x, this one is no, it's not a direct variation. The equation should look exactly like the direct variation equation. And our last one, f of x equals 1/7 times x. Again, we want it to look like f of x equals k times x. So it should be a number times x. So when I look at this piece here, it's 1/7 times x. 1/7 is k. It's our constant value, and we're only multiplying by x. So this one is yes. This one shows a direct variation because it's clearly showing a number times x, which matches our direct variation equation. Just examples of how to use direct variation equations. You're going to get a problem that states y varies directly with x. So the output varies directly with the input. And they're saying that y equals 54 when x equals 9. So they're telling you that this is a direct variation, so we can use this equation, our direct variation equation, so k times x. So we need to determine the direct variation equation, so what the value of k is in the equation, and then determine y when x equals 3.5. These problems are kind of two-step problems. You first have to find k, and then set up your new equation and answer the second part of the question. So to find k in our equation is multiplied by x. Remember from our note sheet that you have, you could also find the constant k equals f of x divided by x. So y divided by x. So this part here is showing us our direct variation. So if we were to find k, so 54 divided by 9, because k is f of x divided by x. Our f of x value is 54, or y, f of x and y are the same, and our x value is 9, so 54 divided by 9 is 6. So our constant in this entire relation is 6. This next step, write the direct variation equation. We're just using this f of x equals k times x. Well, k is our constant value. We already found k. K was 6. So the equation we want to use is f of x equals 6 times x. So now the last part, answer the question in the problem. The question in the problem is this part. Determine y when x is 3.5. So we know that k is already 6. We have to replace this 3.5 for x and for x here. So f of x equals 6 times 3.5, and if we multiply that out, 6 times 3.5 is 21, so f of x equals 21. So this is saying for this direct variation, y is 21 when x is 3.5. And the reason why is because we're using this constant value of 6. Trying another example with that, it says f of x varies directly with x, and f of x is 20 when x equals -4. So they're telling us this is a direct variation equation, so we can use our direct variation equations that they give us. So k times x, and if we're trying to find k, it's easier to use k equals our f of x value divided by x. So f of x divided by a -4, or f of x is 20. So we have 20 divided by a -4. This is going to give us our constant value because we're using our constant equation. So k equals -5. This is our value for k. Then we have our direct variation equation. We want to use our new value of k in that. So it would be f of x equals -5 in place of k times x. And now we can finish solving the problem. To finish solving the problem, we want to find the value of f of x when x equals 2. So we already know that k is -5, so we're going to replace 2 in for x. So f of x equals -5 times 2. F of x equals -10. So again, with these ones, they're multiple step problems. Find k first, set up your equation, and then finish solving the problem. Finally, looking at the graph, y varies directly with x, and y equals 9 when x equals 3. We can graph a direct variation. Again, it's a straight line going through the origin. So we first would want to find k. So k equals y divided by x. So in this problem, k equals 9 divided by 3. Our constant value is 3 then. So k equals 3. So setting it up with our direct variation equation, f of x equals 3 times x. This 3 represents our slope. And if we know that this line has to go through the origin, because it's a direct variation, we can use that slope of 3 as to find our next point. So up 1, 2, 3 to the right 1. Here's 1 point on that line. Going this way, down or left 1 and then down 1, 2, 3. Here's our other point. And if you weren't sure to just use the slope in that way, you can also use this as an equation and choose x and y values. So if I choose values for x, I can multiply into this function and find what the value of y is, or that f of x value. So if I were to say, if I were to put in 1 for x, 3 times 1, my f of x value is 3. Well, if I check on my graph, if I were to put in 1, I got out 3. So if I were to put in -1 to get the other side of my graph, 3 times a -1 equals -3. So when I put in -1, I got out 3. There's the other point on my graph. So you can set it up where you know that the slope is 3, and if it goes through the origin, you can use that slope, rise over run to get to the next point, and then this way too, down and left is still a positive. Or you can set up your table, choose values for x, calculate into the function, and get your output values for y and graph those ordered pairs.